Good morning, everyone. How was the party yesterday? I'm glad you guys have made it. I'm glad we have you guys back. So my name is Wachtang Satran. I'm Voice TSP at Microsoft. And I've got co-presenting with me Nathan Chapman.
Hello.
From Generation E. And he is the only Lync Microsoft Certified Master in Australia. So here we go. We have the whole knowledge here. So we would like to talk today, present you actually setting up on how to set up and deploy the Edge services. Just cross-check, anyone is using Edge today as it is? Can be R2, 2007, or Lync? Okay, great. Usually we say it takes probably 3 minutes to actually make Edge part of your topology, roughly 3 minutes. It takes around 10 minutes to actually deploy it. It's actually quicker to deploy Edge rather than deploy the operating system on a server where actually Edge is running. But it will take you days and weeks to troubleshoot it, to understand actually why thing is not really working. So we thought, rather than tell you just simply you deploy this and do these clicks and drops, we'll give you actually the understanding what are the protocols actually running behind the Edge and why Edge is behaving in a certain way or why the clients are working in a specific way. So we'll talk about the protocols, we'll talk about how to deploy it basically, we'll talk about a very interesting point which is a load balancing, what you do with load balancing, we'll talk about specific rules and some of the elements that come with the Edge like reverse proxying, how the authentication works, and very, very common topic for discussion between us, Microsoft, and our customers and partners, federation. What you really need to open on the firewalls, what you need to close, and why actually, how things are working when you federate, I'm in presence, or if you're actually doing audio video. Just probably some housekeeping. This is designed to be level 300 session. If you are Microsoft, you understand what level 300 is, if you're dealing with Microsoft technology. It is so technical, but we decided to use this opportunity actually once you're here to take it a little bit further. So I can classify it probably closer to 400. We are not going to be speaking about rocket science, but we're going to be actually covering very deep on how the actually trace is going, when the client registers actually, what sort of signaling goes when, why it is behaving. We thought it's a really benefit for you guys to see how things working under the hood. And we have some basic assumptions that you understand SIP, you understand RTP, you understand. We're not going to go and start explaining to you what is actually MRAS server, what is basically front end and why it's behaving in that way. And as a probably rule, we would say, because this is a technical session, can we please leave the questions to the end of the sessions? Because likely we'll answer some of them during the content that's probably coming a little bit later. So we'll have our session, and at the end of the session, we'll have spare time basically to answer all your questions.
And more importantly, our freebies haven't arrived yet. So.
Yeah, so they are on the way. And still rule, if you give us very tough question, as I promised, I double the price. So when it arrives. All right, so I'll pass it now to Nathan.
Thank you. All right, so we'll assume that we have a front-end server deployed. So at that point, we've started to get instant messaging. We've got our presence. We're doing audio and video calls internal in our organization. And at that point, a lot of people get excited when you're deploying Lync and people start playing with it. But typically what we see is the Edge server is sort of the next role that people want to deploy. So start taking that capability beyond the inside of the network, outside the firewall. So it may be for your own users who are either working from home or working on the road and traveling. And getting that seamless remote access. So Lync uses basically an access anywhere type of concept similar to Outlook. So if you're familiar with Outlook Anywhere and the concept of just starting up Outlook, with no VPNs, it just sort of connects magically and all this stuff happens and it's all secure and it's all good. And we get to use exactly the same experience whether we're inside the office or outside the office. So that's what external user access is about. And the Edge is how we're delivering that. PIC is public IM connectivity. All right, so this is federation really with some of the public cloud providers, whether it's Live Messenger, AOL, Yahoo. There's actually ways we can actually add another role to federate with things like Jabber and other platforms as well. We also use the Edge for when we're doing conferencing. So if we send a meeting invite out to someone who doesn't have Lync, they can join into that meeting. They have no Lync infrastructure. They'll either join via a web browser or they download what we call the Lync attendee. So it's a sort of a cut-down version of the client that's freely available to your, I guess, your guests that you invite into your meetings. And the way that they're connecting, again, is through that Edge. So they're coming securely through the Edge server. And lastly here, federation as well. So this is more about, I guess, the B2B relationship that we have with Lync. So if I have another organization that's using Lync or OCS, we can federate with that organization. So I get, again, the same capabilities that I have internally with another organization. So I can look up someone, I can see their presence, I can start an instant message, start an audio, video, desktop sharing, right? So all these capabilities that we have internally, we can choose to federate and share that outside our organization. Actually, so really with the Edge, what it's doing, it's hard to demo because it's the same thing that's happening on the front end. So I did want to quickly just show you basically what the user experience is though, and just as an example that it is basically the same thing as internal. So I've got my laptop here, I'm just on the guest wireless network. So I don't have a VPN or anything. Lync's just signed in automatically. So I can come in now and go to, I'll pick one of our meeting rooms actually. So this happens to be a Polycom HDX. So this is another example of some of those ecosystem partners that actually also supporting this topology and this technology and things like ICE, which we're going to talk about. All right, so that's a meeting room in Melbourne. We'll see that's sort of stepped up to HD now. So this is leveraging some of these Microsoft protocols that we're going to go through to seamlessly get that media and all that signaling through the firewalls and get us connectivity outside our environment. So I'll just flip back. All right, so let's have a look at some of the features that are available depending on, I guess, what scenario we're looking at. So for a remote user, as I said before, you're getting the same experience that you have in the office. So everything that you have in the office, the instant messaging, audio, video, your file transfer, desktop sharing, that's available when you're outside the office and you're on the internet. We get exactly the same thing. Likewise, for federated partners as well, we get that same experience. I guess possibly what's not shown there is one thing that a federated partner wouldn't get access to your directory though necessarily. So they can't just go and search anyone in your sort of GAL and see that. So that's probably the only real difference in terms of functionality though when we're talking to a federated user. So your anonymous users are these meeting guests that are coming in. So you've probably sent out an invite from Outlook. You click the online meeting and you've probably seen that in some of the other sessions. It creates a nice little hyperlink and they can click on that. So when they join, they'll be able to do instant message conferencing. They can do collaboration, so they can do that sort of desktop sharing and see your PowerPoint presentations and that sort of thing. And the audio video conferencing as well. So note there that they can't do a peer-to-peer session because the attendee client that they're using is really just designed for conferences, right? It's not quite the full-blown Lync client. They can't go and initiate a communication. They can only sort of join a meeting. And lastly as well, the PIC with the public IM connectivity. For most of the platforms, all the platforms that we work with, we have presence and instant messaging as a baseline. And then for live messenger, we also get audio and video. So that actually supports high definition audio and video as well. And I think, I don't know if it's out yet, but they did demonstrate at one of the launches the ability to do video to the Xbox as well. So that's, I think, still going to be coming out at some point as well. So that was a pretty cool thing that we've been hanging out for. So you can use Lync, actually do a video call back to your home. I actually use Lync all the time when I'm traveling to do a video call back to my wife and kids. So they're just using Live Messenger at home. So I don't have to have Lync installed at home, but I can call them when I'm traveling. All right, so let's take a look at where the Edge fits into the topology. You've probably seen lots of topology slides this week and start to get an idea of where this sort of stuff fits in. But what we're really talking about is the edge server, and we'll talk a bit about the reverse proxy and what its role is as well. So the edge server is sitting in our perimeter network. Notice that there's a firewall on either side, whether that's physical or possibly a logical firewall on either side. We're going to discuss what the requirements and what the supported topologies are specifically around that, because a lot of people don't necessarily understand that completely. But essentially what's happening here is our remote users, our federated users or anonymous are coming through the edge server. If we have a director deployed, the edge server actually talks to the director, but that essentially then sort of proxies stuff onto your front-end servers. So a remote user will be signing in, they're coming through here, possibly through a director, and they start talking to the front end. So there's actually three sort of roles really, or three key roles that run on the edge, and we'll start to see some of them as we go through this. But basically there's the access edge service, which is basically a SIP proxy. So it's doing all the signaling part. We have a conferencing, a web conferencing server that handles all that sort of collaboration piece. And there's sort of an audio and video relay server as well, which again we're going to talk about. All right, so why do we care about getting through firewalls and traversing NATs? I guess so. What are the problems that we have? Someone tell me, I guess, what happens when we set up a call that the NAT presents a problem for? Yep. So, but if I just send a SIP message out and say, yep, I want to do a video call, here's my IP address I sent my message from, what's the problem with that? Yep. Right. So what's actually happening is in the signaling, you're sort of saying, yep, here's my SIP invite, saying come and join me. And by the way, that doesn't usually go direct to the other endpoint. It's going to go through some SIP proxies or registrars to get there. So the actual IP address that the FRN says are coming from is not the client. All right? So that's why we have these protocols that actually establish where the media path is going to go. All right, so we're going to start talking about how that presents a problem as well, because although we're doing NAT on a firewall, most firewalls don't necessarily know to go inside the packet and change the IP addresses of where my media is going to terminate. So we're just going to cover a couple of acronyms and terms just to put this in context as we talk about it. So a candidate is a term used as part of ICE and sort of in context of all these other ones, but really it's a combination of an IP address and a port. So it's basically a socket that I'm going to use for audio and video communication, and also some metadata stuff as well that happens we'll talk about. NAT, hopefully everyone knows what NAT is. Turn, so turn is basically the concept of using a relay server. So a turn server is a server that you trust as a client, and the server also trusts you. So we'll also touch on that, about that, how we verify that the server actually trusts us to use it. But it's like a third-party relay that we can basically bounce our media off as a mechanism of getting around some of these firewall and NAT issues. Stun is a protocol that essentially what it does is it tells clients what public IP address they're behind. So if I'm in a typical corporate network and I open my web browser and go to what is my IP, right, it'll come back and see a public IP address. It's probably going to be the firewall or the proxy I'm behind, right? So stun basically is really just a mechanism for telling a client what public IP address you're actually behind, because typically it's not going to know. It's going to have a private address. ICE is something pretty cool. ICE actually takes all this information about the possible ways that it could communicate, and it goes through a process of testing every possible path and eliminating the ones that don't work and negotiating which is actually the best path to send our media on. Okay. So if we have a look at sort of typical home NATs or typical NATs in general, NAT was really devised as a mechanism to conserve IP addresses. It's not really a security protocol. It kind of inherently, it sort of had some security benefit, I guess, but it wasn't really designed for security. It was more around conserving IP addresses. So that when we have traffic that goes out from our home, in this case, out to the internet, what happens is we're going to have a private IP address typically here. As we go out through a firewall, that gets translated into public IP address. So things responding to that public IP address usually are going to get blocked because it doesn't know what's behind it, because it could be thousands of clients behind here. So any sort of unexpected traffic that's going to hit this is not going to know where to go. Let's take it a bit further and look at sort of typical corporate firewalls. Actually, I want to ask, how many organizations here actually have a firewall topology that looks actually like this with an actual, say, physical inner and outer firewall? Okay, great. How many have a single firewall, but maybe three or four-legged? Yeah, okay. So we're going to talk about some of those firewall architectures and what's supported from a Lync point of view. But if you look at the Microsoft documentation, you'll see that this is always the topology they're talking about, right? Now, you can kind of emulate this with a sort of a four-legged firewall, if you like. If we treat this as one interface, this is another interface on your firewall, this is another interface, and this is another interface. So we basically have two DMZs. We can sort of emulate this model so that in our DMZ segment, or where we're putting our edge server, we always have a firewall between the edge and the internet, and the edge and the corporate network. So that's really the design objective, is to make sure we have the firewalls on either side. But in this case, we've still got issues here about getting traffic through, right? Again, the outer firewall might let a lot of stuff through to the inner one, but it's going to get blocked at some point, and going back out, it's going to get blocked often as well, because typically in corporate networks these days, you want to sort of lock down what can actually get out as well. So you might allow 80 and 443 or something, maybe through a proxy or some web filtering service, but typically they're pretty locked down. All right, so if we take a look, I guess, first at the signaling part of what the edge is doing. The signaling works on TCP, okay? There's a good reason for that is because TCP, we can use TLS. So TLS lets us encrypt our signaling channel as well. So that's why if you see, I guess there's a bit of, I guess maybe debate about whether you should use SIP on TCP or UDP. I guess I suspect one of the main reasons that Microsoft has done this is for the security reasons. So it's secure by default, and to do that security, they're using TLS and certificate infrastructure to encrypt the traffic, and that's one of the main reasons why it runs on TCP. So we can see here that a person working from home, so this is my remote user, he's turned his laptop on. We can see a SIP invite. So a SIP invite is basically the first message that goes in a SIP dialog to say, I want to initiate communication. There's a media candidate, which we're going to talk about, saying, here's an address or a port, or actually a candidate, I guess, port and IP address that you can talk to me on. It sends it through to the SIP proxy. So as I said before, this access edge role on the edge server is essentially a SIP proxy. It takes the message in, and it relays it back on. In fact, it actually would go via your front end or a director or something, but at some point it gets down to the inside client. There's a bit more stuff typically that happens in between the invite and the OK, which we'll show some of that, but at some point you'll get an OK back, and it's going to say, OK, this is the candidate that I can use for communication as well. So media is going to flow through a separate channel, though. It doesn't go through that SIP channel. And media can actually be UDP or, in fact, TCP. One of the cool things I like about Lync is I've taken it out to school networks before, and they're pretty locked down, right? They have lots of content filtering and proxies and stuff, so they can control what students get access to. So with Lync, I can plug it into the network, get my IP address, and put in their proxy, which is only allowing me to send everything through the proxy, and 443 has to go through there. But even though I've only got 443 out, essentially, I can still establish a full HD video call. Because basically what Lync is going to do is going to try all these different ways of doing it, and it will actually, as a sort of last result, it will try sending media on TCP. So I can get through port 443 and actually tunnel through a web proxy. All right, so these, you see these in a few of the diagrams. This represents a candidate, okay? So this is a IP address and a port, or in fact, possibly a pair of them. So before we had the concept device, what would happen is the endpoints only knew about their IP address, right? So they could have potentially multiple IP addresses because you could have a wired and a wireless network, but really they only really knew about what their IP address. They had no way of realizing what actually is the public IP address that they're behind, and if there was any other turn or relay server that they could use. So they would send that out. First of all, that would sort of get blocked by the firewalls. But even if that did actually, you opened up all your ports and got through, you still got the issue of the NAT, right? So this is going to be a private IP address. There's no way from over here to publicly route that all the way through and get back through to that IP address. All right? So the solution to that is these protocols, stun, turn, and ice. So we start adding in now this AV edge. So this is one of the three sort of key services on the edge server. And essentially, it's a stun and a turn server. So what we just starts doing now is when we sign in, that we're going to talk a bit about later, about some of the processes about how we discover that server and use it. Basically, what the client can now do is, first of all, see its stun addresses. So again, stun is the address that they are natted behind. All right, and we've got two here. We've got a TCP and a UDP candidate. So our turn addresses are ones on this third-party device. This is a relay server that sort of we trust, and it trusts us, so that it'll relay media on our behalf. So again, here we've got some candidates up there. All right, so if we look at that scenario again, we send an invite. This time, the client is going to send a list of candidates. It's going to send all these ones, right? And so it's pulling some turn candidates, pulling some stun candidates, and it's getting its local address, and it's saying, these are all the addresses that you can communicate with me on. It does nominate also a default address, I guess more for legacy support, for things that don't support ICE. So these protocols are all standards-based protocols, okay? All right, so let's take a look at the process of how we find out what these addresses actually are. So I think actually Vartan's going to talk a bit about probably what happens before this point, but there is actually a process where we need to establish this trust with this server, right? But just as we start setting up the call, so we just make a video call, one of the first things that happens is it goes in and quickly grabs an allocation of these addresses that it can use. So it's talking to the media relay server, and it's allocating it, saying, yep, you appear to be coming from this public IP address. And by the way, you can also use these candidates here that I've got, and I'm going to reserve them for your communication that you're about to make. Now, when it reserves these, it actually opens them, I'm pretty sure it's for 10 seconds. So these is, if you've seen it done at an edge server, this is typically the 50,000 port range. Now these don't necessarily need to have them open to the internet. You'll see some of the port requirements for Lync, but we won't go into it. But it's sort of internally, they're sort of reserved on the server. Whether or not the ports are open through the firewall, they are actually allocated and do exist within the media server. All right, so we can see here in the client now, it's built up a bit of a matrix about, okay, these are my candidates I've got. It's picked a default one, which it probably thinks is the most appropriate one to use. Okay, so that, by the way, that was in the audio-video context. So in this context, as I said, we'll prefer to use UDP because it's going to be less overhead and we don't have to wait for acknowledgements every packet we send or wait for our windows. But we do have TCP there as well, again, as a fallback. If I can't get a UDP session through, I'll go TCP. Desktop sharing. Desktop sharing in Lync actually uses RDP underneath it, so it sort of basically is tunneling RDP through port 443. So RDP actually has to be TCP, so we'll notice in this case we don't get any UDP options. But similar things happening again. We've got a local address we can use, we're getting a stun address, and we're getting a turn address. So again, it's built a local candidate list. It's picked one that it'll use as its default, which is the most likely one that's going to work. And it's now ready. So let's have a look at now, I guess, end-to-end what's happening. So already you can see here, this endpoint has already discovered that it's got these candidates available. So it's local address, it's stun, it's got some turn addresses. This is actually probably an example of, this is probably a federated call, because we've got 2 turn servers here. So imagine this is company X, this is company Y. This is company X's edge server represented here, and this is company Y's edge. So that's what we've got 2 turn servers. All right, so the SIP invite goes out, and the client sends all its candidates across there. All right, so now the far end knows, okay, someone's trying to start a communication with me, and he's told me that I can communicate on these ports. So I'm going to reply back once I've discovered what my candidates are. I'm going to reply back with what my candidates are to the other end, so it knows how to communicate with me. Now this 183, has anyone heard of early media in terms of SIP? Yeah, if you've looked at gateways and session border controllers and stuff, it's a common term you'll see around. This is really what early media is about. What's happening here is the endpoint is already sending back and sending back its candidates to work out where it can establish a media path before the call actually finishes setting up. So as soon as I've sent this back, these clients actually can, the next thing they'll do is actually start testing all of those combinations of ports and candidates. But what it achieves is the media path will be set up before the call essentially finishes the signaling. So that, because if you don't have early media, what you can have is with a SIP call, if you set it up, you might pick up the phone and say hello, and the person might miss the hello, okay, because it's still trying to work out which is the best media path. Right? So early media is about this using some of these SIP messages to earlier on in the dialogue establish the media path. So by the time you say hello, the media path is already established. Okay. So in between this, there's a bit more that happens in between these SIP dialogues, but basically at the end, you get a 200 OK, which is basically, yep, we're ready to go, we're talking. And at that point, it's basically confirming again, because after this, it's going to go through some candidate tests. So basically, it does a bind request to each of those IP protocols, IP addresses and ports, and tests which one is actually going to let me communicate with it.
So just to note at this point, once you have 183 session progress, you will establish also codec, because in the original SDP messages, you will have the codecs actually, the clients will exchange the codecs they can actually use. So you may, on the level of 183 session, you may already starting your call, roughly within the 10 seconds, up to 10 seconds, the 200 OK will come. It may take up to 10 seconds. It may be completely different IP address, the pair actually where it will be established, and your codec actually might change. So that behavior is actually just designed to be in this way. There is no, if you're coming across the issue that it establishes one codec and suddenly switches to something else, then you really need to go through some of the logs and understand why the candidates are changing. Might be network conditions are different, might be some jitter loss or some of those parameters. So that's possible.
Yeah, in OCSR2, I think we'd always prefer to use RT video. And if you're doing a PSTN call to the gateway, it would start with RT audio, start with that, and then if it found that the network conditions were okay, it would actually flick back to G711 because it was more efficient. Potentially, didn't have to. It's more efficient for the gateway and other devices because it's less CPU load, and it could actually flick the codec mid-call. So it actually found basically a gap in the audio and look for, has a bit of logic about how it flicks, but it can actually change the codec mid-call and you wouldn't even notice. All right, I'm going to, this is basically what these candidates look like inside a SIP packet. So I'm going to jump across to Snooper and show you what this looks like in a trace. So Snooper, if you haven't used it before, it's in the Lync resource kit. To get these sort of traces, you use the logging tool, and you want to typically log either the SIP stack or the S4 option, and that was going to get you all this SIP information in your trace. So I've just got one here from earlier that I pulled up. So you can see I've got a SIP invite here. If we scroll down, so at the top there's actually a few sections here of
bring it up, magnified.
Yeah. So there's a few sections here that have got candidates in them. So basically there's some backwards compatibility support for clients that don't support ICE and that sort of thing. So there's quite a bit going on in here. I'll go down to the section here. So in here, point out a couple of things. What we're seeing is this list of candidates, so we've had them allocated. And this is the invite, so this is the initial communication I'm sending out saying, I've got, all right, so is a UDP port I've got available. Notice that these are all in pairs as well. So I mentioned earlier that there's basically some metadata that goes on. And I think Vakhtang talked about it yesterday, but when we set up an audio call, there's actually two ports we need. There's one for the media itself, so the RTP or SRTP traffic, and there's one for RTCP, it's a real-time control protocol. So that control protocol is really metadata about what's happening with the audio or the video. And Lync uses that in a pretty cool way to actually dynamically adjust the codec and adjust what they call it to adapt to the network conditions.
And usually RTCPs are all odd ports. They never use the even ports.
Yeah. So we've got a few things here. So this big number in here is actually a priority as well. When we send out my candidates, what's the highest priority candidate you think I'd send out? Which IP address would I prefer people to use? Yep. Yeah, that's right. So you see local address. Because what actually happens, even if I have a client it's on a corporate network and I've got someone on the next desk sitting next to me, it's still going to send all these options, right? Because it still goes through the process and talks to the edge every time if it's available, if it's been provisioned. It will talk and get all the options to find the best media path. So even though I'm sitting next to someone, it's still going to tell me you can talk to me via this public IP. But what we want to make sure that if they're sitting right next to me on the same subnet, I want to talk direct, right? So the media stays in the most efficient path. So there's a priority there. We can see we've got some public IP addresses happening. And you'll see here that notice there's also some UDPs and some TCPs. We have some active TCPs, which means they're ones that I can both send and receive on. There's passive as well, which is ones that I can only send on. Yep. That's because it's coming through a firewall and that port may not be open. So this is just really to highlight, I guess, this is what it looks like in a SIP packet. And this is part of the session description protocol, which is it really goes along with SIP. So the session description protocol is what we're using to establish our media paths, and it also describes our codec. So when we start looking down, scroll down a bit further, we start to see some of the, scroll down a bit, start seeing some of the codec options. All right, so down here is our codec options. So we've got PCM, which is G711. We'll have RT audio. What else we got? There's the RT audio up there. The different bit rates that are available as well. Different sampling rates. So this is part of that negotiation of this is my capabilities. This is how you can talk to me. Okay. So if we went back and looked at either the 183 or the OK message that comes back, we're going to see similar information. In fact, do you want to, let's quickly jump to the OK.
Yeah. Minus.
I think it's
okay.
I think it's the second one actually.
Magnify.
All right, so see here, my list of candidates. I just got two ports now, two candidates. So it's eliminated all the other ones by doing these tests, and at the end it's just said, cool, these are the ones we're going to use. And notice in this case it happened to be UDP. All right, we'll flick back. All right, so now I'm going to talk about some of the architectures that are supported for deploying the Lync. So we're going to start off with some of the single server topologies, and then Vakhtang's going to talk about some of the dual server high availability and load balancing topologies. So if we have a look at the documentation for Lync, in TechNet, there is, under the planning section, under external user access, I think it is, there's a section here and it has some reference topologies about how to deploy this. Essentially, this model here is the only supported model from Microsoft. This inside is an inside and outside model. So in this case, we're talking about physical external firewall and a physical internal firewall as well. And also, we note that these, the outside segment here and the inside are actually different subnets. And these shouldn't be able to talk to each other directly. So there's no actual connection between these two firewalls. It actually goes through all these, there's basically assumptions about the topology that you're deploying. So the only path really to get through is through the outside interface, through the edge in the inside interface. Then there's a second layer of firewall rules that come in and kick in here. So there's only one port we really allow from the edge back into the corporate network. But yeah, that's really the only supported model. So I asked before that there's a lot of people that don't have that model, and I find that it's not necessarily, and especially in a larger enterprise, it's pretty typical because it's really a strong model of how you do your perimeter security. But a lot of companies might just have a three-legged firewall, right? So they've got a single appliance, they've got a DMZ interface. So our approach there is basically to do this. So I said a three or a four-legged firewall. So if you make that a four-legged firewall, and we create two DMZ segments, okay? So we can sort of emulate this in a single box. So this is, I guess, the next best thing to that, because essentially we're getting the same rules. I guess from a security perspective, we'd say, okay, if this was compromised, then you got straight in. But whereas in this case, if your outside firewall is compromised, there's still another layer. So it's not quite as good as this. But certainly in terms of getting the firewall rules both sides of the Lync Edge server, this would be the next best thing.
So the most important message is that you really need to separate your outside and inside networks by different subnets. They have to be different networks. That's the supported configuration for Microsoft.
Also, a lot of people, because they look at this and they think, yeah, geez, it's a bit confusing and it doesn't really suit our topology, they will actually put their inside back on the corporate. So as you can imagine, that's probably not a good security decision to make because this is a public-facing DMZ host. It's not a domain member for a reason because it is a security or a DMZ device as well. We don't want it part of your domain. But yeah, again, if that was compromised and it was directly on your corporate network, then you can see what could happen there. So yeah, it's not supported, not recommended to put that internal interface on your corporate network. So that's why we want essentially two DMZ interfaces. The last one, which I wouldn't recommend at all, in fact, I'm not even sure if it works. I've seen people try it and we had issues. They had issues. So this is actually putting them both on the same network. First issue you have with that is there's some routing issues because you've got two interfaces and you'll find that a Lync server will use the wrong interface when it tries to talk to your internal network. You can fix that with some static routes and telling it which interface to go out, but they still had problems with it. And again, it's not supported anyway because the supported topology does say that this and this have to be separate subnets. Okay, so that's what's supported. If you want to find out more information, there's some really good diagrams in TechNet that explain it and explain how the natting works and where natting is happening and that sort of stuff. So talking about NAT. Another interesting thing. So who deployed some OCS 2007 edges? Yeah, a few people. So what did you have to use on your external interface? No, 2007. Yeah, not R2. So on your external interface, you had to use a public IP address. It had to be routed all the way through to the edge. So the actual network interface had the public IP. It couldn't be natted. In R2, they sort of fixed it, and there was support to be able to NAT that. But the funny thing is, I guess in Lync, is actually now mandatory, essentially, to do NAT, except for one scenario. So if I have a single edge, single server, I obviously don't have high availability. NAT is mandatory in terms of support. Now, I know for a fact that putting a public address on it will work. This is what is supported, though. This is what Microsoft has tested. And it actually suited most organizations anyway to NAT. Most people would assume that's how you would do it. As I think a lot of you found, especially for partners, if you did an OCS deployment and you said, oh, I have to get public IP address, it could be a real pain because their topology wasn't set up to have a publicly addressed DMZ necessarily. So when I have a single edge server, I don't need additional DNS records because I've only got the one server. And we obviously have no failover being a single server. In a scaled edge, so this is 2 or more edge servers. If I'm using DNS load balancing, so we're actually achieving DNS load balancing by publishing multiple DNS records for each name. So for sip.contoso.com, it'll actually be 2 records, and each record will point to the public IP that's associated with each edge. So the public IP is not necessarily going to be on the edge, but it'll be native to it. So in this case, we can have high availability because in Lync, for DNS load balancing, the smart's built into the client and all the pieces of Lync to be aware of DNS load balancing. So when it goes and looks for a server name, it doesn't just grab the first response that DNS comes back with. It collects them all and says, okay, I'll try this one. If that doesn't work, I'll try that one. So it's key to note that the smarts are actually really in the client side of the communication.
Just to confirm, that DNS load balancing is a round-robin load balance. That's the load balancing. It's not the SRV records-based load balancing. If Lync, in a normal DNS load balancing on a network, Lync client actually will get multiple records with the different preferences. With this DNS load balancing, there's going to be 2 records, and basically he will try one or another.
Yeah, good point. So the actual the HA part of it is really using the SRV records, not so much the DNS A record. But no, in that scenario, NAT, again, is mandatory. You don't put public IPs on your edge interfaces. You NAT them from your firewall through to private IP interfaces. And in that case, what's the failover referring to? Okay, so so failover, this is referring to support for, I guess, legacy systems that don't understand the DNS load balancing. Because again, I said the smarts in the load balancing is really in the client side. So if you have an old Exchange server or something, or a legacy client, it won't understand the DNS load balancing and won't be able to necessarily fail over to the secondary server. So that's what it means by it. It doesn't necessarily have failover. It's more about the legacy support. If we have a hardware load balancer, so this might be like an F5 or A10 network sort of, or a Cisco load balancer, right? We can, obviously we have high availability, we've got multiple servers. We actually have to use public IPs in that case. And in fact, we end up consuming a lot more public IPs because we have them all over the place. We have a virtual set of IPs, and then for every edge server you have another set of either 1 or 3 IP addresses. I think we're going to talk later about it. You can actually have 1 external IP address. It's strongly recommended you split them out to 3 though, because I think we've got a slide that talks about it. But yeah, by using the 3 individual addresses, essentially you're going to get through a lot more firewalls and you have less issues with the clients connecting to it. Okay, so I guess there's a diagram showing that single IP address. So again, this star is representing this as a public IP address, okay? So we've got a firewall and NAT here that's NATing that back to a private IP address. And this is with a single IP. Now, note, I just said that we prefer to have 3 IPs. The reason is, if I have a single IP, remember I've got 3 services that are running. There's the Access Edge or the SIP service, we've got the web conferencing, and the AV. The AV is this turn and stun server. Because I'm only using 1 IP, I've got to have unique ports for each service, right? So if I'm a client, again, I'm back at that school network and I put in their proxy and go to connect, cool, I can get through to 443, but I wouldn't have been able to sign in because they're not going to allow me to get out in 5061. So what we can do, you'll see in the next slide, is we can use port 443 essentially for everything by having a different IP address for each service. So again, coming back to that Intel interface, note that interface is a different subnet. This is not the corporate network. There'll be still another firewall that would be over here. These are some of the ports that are required back on this side for communication with the internal network as well. There's some really good documentation on TechNet and tables about the ports required between your corporate network and your Edge internal interface, and then from your Edge external app to the internet as well. All right, so if you're going to do this, there's a tick box in Topology Builder to say use a single IP address, okay? Because that'll basically ensure that you're using these unique ports. Okay, so this is, I said, probably a more recommended approach. At this point, we're still talking about a single Edge server. But now we've got 3 public IP addresses, 1, 2, and 3, and they're, again, natted to 3 separate private IP addresses that are on our external interface. Now notice in this case, I can use port 443 on each. So 5061 is actually there for, it's usually there for federation. So you'll see in Topology Builder, if you enable federation, it needs 5061 there. Conferencing, again, 443, and 443 down here. The 3478 is actually a UDP port that's open as well. It's another way that it will try to get through. But if that's not available, it can fall back to 443. Again, same sort of thing on the internal interface. But in this case, our remote users are going to be able to get connection to our server and be able to log in a lot more easily because they can just get through 443 in any case. Now, you'll see a Topology Builder that it does ask for, when you do this, it asks for a public IP address. It needs to know what one of these IPs is. The interesting thing is it doesn't tell you which one you need to know. So a lot of people get caught out on this. Sorry, yes, question.
Are you implying that the outside of the Edge service requires 3 interfaces?
Yes. Essentially, it's 3 separate services running on there. Think of it as 3 applications.
Okay,
Sorry, not 3 physical interfaces. No. No, so these are often one physical interface. You just bind multiple IPs to them. Yep. And of course, it can be virtualized, so it can be a virtual NIC as well. So in Topology Builder, it asks you, when you're doing this, for what the public IP address, and it only asks for one, doesn't want to know what the other ones are. It doesn't say which one, but it's actually asking about the audio-video one. This is the one that's used for turn and all that media traversal, right? That's the one that's important, that it needs to understand what that is and what it's natted behind. So a lot of people get caught out on that. If you put in this one, you're not going to get media set up. You'll be able to sign in and everything, but you go set up a call and the media will fail or say there's a network issue. And it's one of the first things you should check is make sure you've done that correctly. All right, I think Vakhtang's going to take over and talk about some of the high availability options.
So if you've seen, we put a message that if you are deploying Lync, you have to use DNS load balancing with hardware load balancers. With Edge, you have got an option. You either can use hardware load balancers or you can use DNS load balancing. So in case of doing the DNS load balancing, you can have multiple edges. And basically what you need to do, you need to publish specific A records for each actually of the addresses. And what it will do, it will actually DNS load balance across those IP addresses based on the client's request. The only thing you need to do, you need to make sure on the Lync configuration parts, you have to make sure, let's say, if this is the IP3s and IP6 are dedicated for audio-video conferencing service, you need to make sure this pair actually is configured and Lync knows about those actually natting that's happening. Another important point, which we're probably not highlighting here, but it's worth mentioning, certificates. It is very important to make sure that both Edge servers have the same certificate. Basically, same certificate. You import one and then export and apply the same certificate to another one.
In particular, it's the AV authentication, I think, certificate.
Yes.
That needs to have the same private key on each server. Yeah. So you do it on one server and export it to the other one to make sure the private key is the same.
Yeah. Because when when client will come in, and if it's load balanced, and let's say if he's been actually assigned to the first server and the server is down, if the keys are different, then you'll have a problem client signing into the second one. So that might be an issue. Be aware of this. In case of the hardware load balancers, well, you really publish one set of one set of IP addresses, but the problem is you're going to consume a lot of public IP addresses. So if you have a lot of them, and if Apnic didn't grab some of them back, so that's probably some of the scenarios. But well, that's what it is supported. Again, no much changes in the operation. You need to use, and in this case, you no need to let the actually Lync server knowing what the netting. There is no netting exist in this case. So how many of you have done coexistence of Lync and OCSR2? Yeah. The edge is really critical point because you have existing users. We can coexist those two guys, the OCSR2 edge and Lync edge, except federation. You only can have one server actually. If you are federating with someone, you need to make sure that's the only one server. And usually for federation purposes, you either do it first or either do it last. But again, it's a very important when you do the migration, plan for how you're going to handle that federation, how you're going to handle the remote access. So also some of the information for you, the legacy elements, they do not support load balancing. So make sure you publish the records and all correctly that old clients cannot go and actually do the load balancing if they are coming to the Lync edge. Again, there's a lot of planning involved while you're doing that. Let's do the quick demo of the topology builder. So we know about the edge, we know about the architecture. So hopefully we've done the right architecture, chosen the right technologies, IP addresses. So let's understand how we build the edge. And then just after that quick demo, we'll dive into how actually edge are talking to each other.
So the topology builder is where we define what our Lync architecture looks like, our Lync topology looks like. We define our servers. And in the edge, you notice in most of the things you define in here, they don't care necessarily what the IPs are. It's all sort of name-based. But on the edge, it does need to be aware of what the IPs are. So we have an internal server, FQDN, in here. So that's what your front-end server is using to communicate with the edge. So that's basically resolved to that internal interface on the edge server. And that's its IP address there. Note there that if we have federation enabled, it does enable port 5061 as well. So we need to open up that on the external side if we want federation. This is the public IP that during the wizard it'll ask you for that public IP address. Now again, stress again to make sure you put in here, it's the public IP address associated with the AV interface, not any of the others. Port 4443, that's actually a port it uses on the internal interface for the replication of the topology because you do your configuration change on the front end, that actually stores it in the SQL database and the CMS database. That then gets, for internal servers, it actually replicates through file shares. But because the edge server is not a domain member, it can't necessarily get that information through file shares. I mean, it's actually locked down anyway. So the way we replicate topology back to the edge is the front-end server will do a connection out to the edge on port 4443, and it basically pushes the topology out to it. So that's why in OCS when we configured allowing and blocking of domains, we had to go out to the edge server, open up an MMC console and do config there. Now it's all centralized, and this is a mechanism for doing that. Here we have to associate the edge with a front-end pool. So that's the front-end server that it's talking to. And down here, here's our three services. So our SIP access. Note that I've got private IPs on these because the public ones have been natted to it. And in this case, I've got 443 on everything. So I'm going to be able to get to this through lots of different corporate networks and stuff because I can get through on 443. So that's what the edge looks like in topology builds. That's what you said. It only takes 3 minutes or something to actually define that in topology and publish it. Actually, just one thing to note, when you publish this the very first time, to actually install on your edge server, you have to run a PowerShell command to export the topology because it doesn't have that 4443 service running yet for it to get it. So the first time you get topology out to your edge server, you have to do a export CS configuration to a zip file, copy that to your edge, and it will ask you for that when you run the setup and that's how it knows how to configure itself.
Let's you do it only once, the first time when you deploy. And after that, it will actually communicate over port
But once you've got that
4443.
port 443 up, it's automatically replicating out to it. Right.
Okay.
The protocol on the AV service is TCP as opposed to TLS. Is that for a reason?
Yep. Big.
Sorry, for a reason. Sorry, what's the reason?
I think that's default, isn't it?
It's a default protocol.
But you can use TLS?
You can.
Well,
You can. But then if you use TLS, your anonymous users won't be
not
able
really,
to.
because the encryption in the media is done by SRTP, not by TLS. So that's why on media, if you are using TCP, because what this is saying is, or actually it kind of is TLS, because it's 443, it's tunneling through SSL, which is TLS, but I guess this is a terminology thing. I guess in some cases you consider it is TLS, but
The question is the audio, video encrypted?
Yes,
yeah, it is. It's encrypted
It is.
with SRTP, though not necessarily
The
TLS.
media path, nothing has to do with this. They will use SRTP level to encrypt that.
Yeah, and I think that's more talking about which port you need to open on your firewall. It's a TCP port, and TLS is TCP port as well.
All right, reverse proxy, if you are using some of the content, the reverse proxy, not mandatory deployment within a topology, as you've seen, but it is necessary to deliver some of the rich content back to the users. For example, if you're doing a desktop sharing or in a conferencing, you're pushing some slides, if that's your deployment, then you need a reverse proxy. What the reverse proxy basically will do, it will take the old HTTP and HTTPS traffic coming out of the web services from the front end and actually will push down back to the users. So it has to be there if you are using that sort of functionality. For basic IMAN presence and just the conference calls, you don't need to see reverse proxy. So we've seen a lot of the implementations going IMAN presence and basic conferences without reverse proxy. But once you start pushing the content across, so you need to actually use the reverse proxy. Plus, some of the services like address book sync up, or if you have got IP phones and devices outside of your network, if they need to be updated. So there is a way of bridge front-end server back to this, because Edge doesn't do any of this stuff. So you need to have reverse for this. Now, one of the reasons why we have a lot of questions about the UAG deployments of Microsoft UAG on the networks, we do not support 4443 mappings on the UAG yet. It's coming. So that's very important that when you choose a reverse proxy, make sure that it will do this 4443 mapping in the backside. Usually, reverse proxies will map port 80s and 443, but we will require further to go to different ports. So be careful when you choose reverse proxy. I don't think so we have a list of certified proxies, but just talk to us if you're going to use something else. I think the TMG should be...
TMG is fine, yeah.
TMG is fine.
Or ISO is still good
yeah,
too.
the only thing the issue is that we UAG universal access.
You can actually use some of the actual load balancers that are doing layer 7 can do this basically as well. So.
All right, let's go to more cool, interesting stuff. So authentication, how the users sitting outside, they actually getting authenticated. And this is probably happening while you first time log in inside. The same process would happen if the user endpoint will be inside. But let's have a look while the user is outside. So user basically will send a message to the via Access Edge server to the front-end server requesting that he would like to actually come in and register. Once that actually happening, Lync server actually will will authenticate the user, do a lot of stuff, issue certificates, everything, and part of the policies and all information, Lync server frontend also will pass the MRAS information, which is Media Relay Authentication Server information, which is your edge. So once the endpoint receives that information, then endpoint will tell the front-end server his location. Now, this location can be actually internal too. So the same process endpoint goes, I want to stress you out, while you are internal. Once it knows the location of the server, of the endpoint, the front end, on behalf of the endpoint, will actually register the user back to the Edge. But Edge doesn't remember every user. What Edge will do, Edge will issue specific credentials for this user, and those credentials will be valid for 8 hours. And then Lync server front end will send back 200 OK message with his credentials, with username and password, with the duration of those actually, and which port actually this guy can use. So once this information is received, then whenever that endpoint will be joining your edge server, endpoint actually will be using those credentials to log in. And this is a very common question we get from the security guys. When you ask them to open, let's say, 50,000 port ranges on internal network, not on external, on internal. Firewall guys will say, I'm not opening any port ranges at all. But actually, fact, when you say you open the ports, you don't open them. The ports, first of all, are opened on a dynamic fashion when users request them to open. And secondly, users, first of all, have to authenticate against the edge. And when it is authenticated, then edge actually dynamically will open. So if you have any situation where security guys don't want to do anything, I think the best way is actually to go through this process to let them know there is a bit of authentication mechanism. So you trust an endpoint before you open a port for them. And the same thing actually happening with the anonymous device who is outside joining the conference. What will happen? Imagine this is when an anonymous guy trying to join a conference, you send someone a message that I want someone to join my conference. What will happen? Your MCU, which is sitting somewhere here on a Lync front-end server, same process, MCU will request some specific credentials for that anonymous user and will send the credentials, and then an anonymous user will be able actually to join the conference and start actually receiving media. So everything have to be authenticated. You can't have someone coming in and listening to your conferences without being unauthenticated at all. From the security side, well, yes, you need to use a separate subnet. It is all, everything is, if you have a look, is a bit of security sit behind. The signaling is secure. If you have a look at this, the edge server is not part of your domain, but there is a bit of certificate work actually going, because when you have establishing trust relationship between edge and the front end, edge actually uses those certificates to issue those usernames and passwords which are random. So we are recommending you to sandwich actually edge between two firewalls, but if you are not having physical two firewalls, so there is some work needs to be done to make sure your edge is completely isolated. And we've got some security guys that actually part of TechNet. This presentation will be available. You can actually click on those links and get those security guys, read through them. Again, the question is, everything is secure. So the signaling is secure. MTLS, we use mutual TLS when in server-to-server communications. We use TLS in the client-to-server communications. And the media is encrypted by itself in SRTP streams. The only thing we don't encrypt media, we do straight RTP when you do media bypass to the certified gateway on a certified endpoint, which means that you need to know who is this endpoint actually. We know who is endpoint before actually we do the unencrypted channel. So federation, it's a very interesting point. We federate with our partners, we federate with our customers, and it's a bit of guide. If you ever done Lync planning tool, it comes back with a bunch of the ports. It outlines very nicely your firewall interface out in. These are the ports you have to open. These are requirements, but let's go through the slides we actually understand what you need to open, because the combination of the ports you need to open, it depends with whom you federate, and with whom I mean which version. Is it OCS 2007 to 2007? Is it Lync to R2? Depending on the version, we actually have done some changes. So if you have got 2007, what the default federation is, it's actually we are supporting high range of ports, 50,000 to 59,999. Again, these ports are not open, but your federation actually will use your ports. UDP preferred, and TCP if I have to fall back, if I can't make anything. If you do not open those ports, you won't be able to federate. And this was actually in 2007. That was deployed. The whole idea of UDP 3478 wasn't there for the federation. In case if you have an R2 boxes, and what we've done, this has been introduced R2 tunnel mode in federation with R2. Our preferred way would be actually to federate across 3478 ports. So the difference is you cannot go on the 3478, but this is the situation where you have to open outbound session TCP on 50,000 only. This is the situation. Not inbound, just an outbound session, because we couldn't have the situations. TCP is a basically connection-oriented protocol. You need to have a sockets. You can't have multiple connections going on the same TCP port. So we don't do multiplexing, a lot of multiplexing. In this case, which actually will outbound goes, in this case, will be 50,000 outbound goes to 443, and outbound 50,000 range goes back to 443. This is the only case you need to open on a 50,000 range. If you are federating with interop with anything to R2, and this is probably the case with the Lync too, what actually will happen that R2 environment will find out that it cannot operate on 3478 and it cannot operate on a 443, so it will actually fall back into 50,000 range. So this is the situation when you need to open both directions, 50,000 in and 50,000 out. And well, nothing stops you. You still have to open your 3478 for your remote users actually who will be accessing the network, who will be roaming around and trying to do the video and audio actually. That's what will go through your 3478. But if you go on a federate with someone who is on a 2007, they will go through the 50,000 range. And if you are doing a Lync federation, well, it's basically we started multiplexing on the ports. We've introduced some changes. We now we can multiplex on the TCP 443 to TCP 443 because we started looking deep inside actually RTP headers, the RTP actually ID tags. So we're separating sessions by them. That's what you do. In reality, basically, if you have 2007, you need to have basically 3478 and 443, I would say by default anyway, for your communications, but for federation, open up 50,000 inbound and outbound. And in case you have Lync and R2, and if you're going to federate to 2007, then you do, where is it? Here we go, TCP outbound. Otherwise, if you don't have 2007, you just simply do 3478. Now, if you are doing the public internet provider, public IM providers, peak connectivity, unfortunately, they behave like 2007. So if you want someone to if you're federating with MSN Messenger or with Yahoo, you have to actually open 50,000 range. That's the default as of today. Troubleshooting, as you have seen, when a client logs in, client gets a lot of credentials of your MRAS server, gets the user ID temporary, and plus during the establishment, it gets a lot of candidates. This is how all establishment works. So basically, they talk to each other, trying to chit-chat with each other and see which is the best path they can talk. The first troubleshooting will start with your MRAS. And you basically need to open up the logs and see if you're actually getting the MRAS server messages anyway while you're doing a registration. When you register, you get the messages back from front end and there is no MRAS server, then you have a problem. Then you need to look, is the link between your front end and edge is working? And that's happened with me a lot of times when we've been working with customers. They simply completely blocked all communications. Edge sits in the DMZ, and front-end server, they just can't talk to each other. So that's probably the first step for troubleshooting. Then if you're getting MRAS server, but you're not getting credentials, then what is very common that Edge can talk to the front-end, but Edge can't talk to the clients on inside network or outside network. So that's probably the second area of troubleshooting. Make sure your internal clients actually can reach Edge. Once they can get all the credentials from the front end, but if they're not reaching Edge, well, they're not going to be talking. And then if you can see you're getting MRAS, you're getting actually Edge credentials, Then the most important thing to watch, as Nathan showed you, you establish a call, you need to see the candidates. If you see the candidates in a list, it's good. That means you can actually talk. If you can't see the candidates in the list, there is something going wrong.
Especially the public IP candidates, if you're going through the edge. If you're not seeing them, you know that you've got to issue with the MRAS.
Yeah. Logs, basically there is a multiple areas where you can collect logs. You get logs from the front-end server, you get logs from the edge server itself, Snooper tool, yeah, it's, if you haven't been using Snooper, we very, very highly recommend. Go get that Snooper. That's, basically, you should, if you're a technical person working on this technology, Snooper should be the application that you guys use. And basically, in the review of the session, as we said, it can be very easy to install it and deploy, but you can spend a lot of time troubleshooting. So we believe once you understand actually all the processes running in the back, just follow some processes, understand the protocols. That really will help you actually to spend less time troubleshooting and having more time of fun. Thank you very much. And for questions? Yes?
You were talking about the internal connection
Yes.
going through the front-edge server. Does that mean I've got redundancy internally,
Yeah.
but I introduce a front-edge server,
Yeah.
and that then means that if I don't do redundancy there, I've lost my redundancy internally? Because it's always going through that front-edge server to make a connection, even if it's desk to desk?
No. Desk to desk locally will go locally. What will happen when you try to establish connection, you'll get heaps of candidates. Your preferred candidate with a high preference will be your local candidate. You may lose edge, that's fine. But always local candidate will be chosen because they will find out, I can talk to you locally. That's it. Your final candidate, that's 200 OK, will have our just local IP addresses. Yes?
DNS naming for the edge components like AV and webcom.
Yeah.
I know SIP needs to be SIP or access or something dot your root domain, so .com, because external other devices don't like when it's different. Does the same rule apply for AV and webcom stuff like that? So you can go av.lync.com.
You use those names. Whatever use, this is a different. On the edge side, you just need to use the names to resolve to IP address. If you have multiple IP addresses, one for AV, one for web, one for access, use something different.
Or can they be lower down in the tree? Our external
As long as your A record actually points you to the IP address, you should be fine. Yes?
I'm assuming that with everything going green IT and everything else like that, that you're able to use virtual servers to be able to
Yes.
publish an edge.
Yep.
How does this go with high availability clusters?
Okay, VMware base or Hyper-V, no live migration.
Okay,
Yeah.
so
If it's dead, just fire up on another
The HA is
host.
built into the application level, so you
Yeah.
don't necessarily need to move servers and fail over the servers at a virtualization level.
would it be possible with hardware load balancing?
What do you mean?
So with the two NICs, so you've got, let's say for example, two physical hosts.
Yep.
They've obviously got to have separate IP addresses.
Yes.
Yep.
On the physical NIC. So would it be possible with hardware load balancing if that server was to fail over to the other one, that it would resume?
No, you don't get session back. If you drop it, you will actually authenticate back, connect it back. But the problem is, this is where you need the same certificates on the different boxes. Make sure you can authenticate against that one. You need to authenticate back.
But the recommendation in general is do the high availability at the application level using multiple servers rather than trying to use Hyper-V and do a live migration or a HA sort of.
So you're not recommending using a hypervisor?
No, I think it's best typically if it has a HA at the application level, it's usually going to be more tolerant and more expecting to handle that. So.
Yes.
One of the bones of contention I always had in the past with deploying Edge is the certificates used for the AV authentication service.
Yep.
Microsoft have been very loose on the stance of what name should be attached to the TLS binding on that service. So I mean, av.com, do we put that on the public certificate, or is MRAS only going to use the internal certificate?
The AV one doesn't have to be on public. It can
AV
be
no need.
internal,
So
yeah.
I think why you see that TCP in the topology builder, because that certificate isn't down with that server.
Yeah, so I actually usually put it on there, only because when you buy a SAN certificate, you get 4 free names, so you may as well stick it on and make it easier.
The official stance has never been black and white. They say, we think you should use internal, use
Yeah.
that name for your MRAS, or that other people say, use your
Internal, on the inside network, you need MRAS. You can use private certificate. That's fine. On a public network, those two certificates will be used to completely two different things. That's why you can use still internal on inside, and external you can use external certificates.
saying that we don't need to put AV dot, etc. on the external side.
No,
No.
it doesn't need a certificate, but it can be from your internal CA. It's actually used for the authentication service, not for like a web
Yeah.
service.
Yeah. Yes.
My organisation is currently doing IPv6 trials.
Yes.
Away from the endpoint.
No.
Is
No support for IPv6 in Lync today.
on the roadmap at least.
Look, you need to understand, to support IPv6 inside Lync, Lync has a variety of protocols inside. First of all, STAN, Turn Ice, all those protocols need to support IPv6. So it's a much, much bigger work needs to be done. Will it be next release of the Lync? I'm not sure.
If we had IPv6, we probably wouldn't even need an edge server.
Yeah.
Because it all takes care of itself. It does the encryption. And,
Yeah. Yes.
What's the hardware requirements, performance overheads for servers, whether physical or virtual? Is that the usual thing of if you virtualize, it's 50%?
It is actually 50% is the guidance.
Yeah, 50%.
And what sort of physical load does it put on a server?
We've got specific capacity tool calculator, which is Excel based. You can actually fill in and say, this is how many users I have, this is remote, etc., etc. It will come back and tell you this is sort of box you need if you're going to go hardware.
Yeah, it depends on which role you're
Have a
talking
look at
about,
the
but
capacity
use the
tool. It's
calculator.
available on the TechNet. Yes?
Is there anything new on the stats gathering and what traffic goes through Edge?
Edge doesn't report back to monitoring server. You can't do monitoring. So probably, I don't know, basic network monitoring tools will give you some understanding. Yes?
Span multi-site, Edge pool?
Yes, but depends what's at the back.
So you got a front end pool with, between, say, Bristol and Sydney and
Yes.
between Bristol and Sydney?
Look, if you the question is can you span the edge across multi-sites? I would say conditionally yes, because it's like a load balancing. You see, the clients will resolve DNS name. They'll come either to this edge or Sydney edge or Melbourne edge. But the problem is what actually that edge does then, where it goes, where is your front end? If it sits in Melbourne, then edge have to actually come down out of Sydney communications back to Melbourne. If you split your pool, no, but yeah, sorry.
Who are we up to?
It depends. It's design specific. Last question, probably we'll take offline. Come and have a chat. Just off. Yes.
Oh, down t-shirts now.
Talking about DNS.
Yeah.
It's not round robin DNS.
Probably go on. I think the Polycom ones.
Session yesterday where
Round robin. No. It's a round robin.
saying that it is round robin. I was in a session yesterday where they were specifically saying this is smarter than round robin.
No. On a client, for Lync client side, client requests the SRV records, and when SRV records return, it's actually build up to 10
Actually,
always servers.
The SRV is actually more for the regional failover,
Yes.
actually. So it is actually we'll use the A record for if you have multiple edge servers in one pool.
All right. We're pulling off.
It will use the A record actually to find the backup one. But
Thank you,
SRV